This is our main targeting research. And this is the today contents. We will show the opportunistic federated learning system by using the chestnut is based on this approach. So, okay, let's start. Before I introduce about the opportunistic federated learning, I briefly explain about federated learning. There are three major problems associated with the real environment and data processed and trained by remote servers. The first is the network congestions when many users' devices simultaneously send data to a remote servers. And also there are a problem of the privacy leaks. This is that personal information leakage during the transmission process is possible. And last thing is that resource constraints, that limitations are noted in the capacity of network resource and user devices. Therefore, as you can see in these figures, the federated learning is introduced. Federated learning is a distributed learning method to train a huge amount of data generated and to update the model on local nodes, like the mobile, like mobile devices. So learning. Firstly, and repeating all the steps until the end. Now let's look at the application of the federated learning. Information about the current context and whether you click the suggestion. The federated learning process that history on device to suggest improvement to next iteration of Gboard's query suggestion model. And also they are trying to introduce like this. And furthermore, the federated learning will be able to be and this disease diagnostics. For the introduction of federated learning, there are challenging issues that needed to be overcome. First thing is convergence analysis. The federated learning's performance and convergence time will be affected by the user selection scheme because the huge number of clients who participate in federated learning could be effective to converge the model or not. This is because the neural network usually have a trace of the non-convex trace. Second thing is privacy and security. It is possible for eavesdropper to reconstruct the raw data approximately even though the federated learning is quite robust in perspective of privacy. And third thing is synchronous communication. Synchronous communication methods are simple, but it evokes is important. local data is heterogeneous by each client caused by limited. Now, I will explain about opportunistic federated learning. This paper is published by Pervasive, IEEE Pervasive Computing and Communications. Following the paper's definitions, opportunistic federated learning is individual devices belonging to different users seek to learn robust models that are personalized to their user own to plausible data distribution. Then they utilize this diversity by setting their core distribution, which is subset of label the devices wanted to classify correctly. The device exchanges model parameters opportunistically when it fits into the neighbors, that is the encounter. And this is the algorithm of the opportunistic federated learning. The clients are denoted as set of C, and clients I's data denoted as L sub I. Neighbor discovery devices independently execute the onDiscover function. First, clients I compute the similarity between the learner score distribution and neighbors data label distribution to determine whether the encounter will provide a useful learning opportunity following this equation. Then the similarity is more over than threshold tau. He decided to engage with the neighbor to perform a session of remote training. The learner requests remote learning from the neighbor, and the learner sends the neighbor a copy of his current model by sending a model parameters. Then the neighbor loads the models and uses its own local data to compute the gradients, which it returns to the learner. The learner stores the return gradient in the data structure gamma mapped to the label set L sub j. The paper suggests the two of aggregation methods, greedy aggregation and opportunistic momentum. Firstly, the greedy aggregations directly average in the gradients learned by the neighbor after incorporating one round of the local similarity of the corresponding data label weight omega is it uh, it is it to address to overfitting to the inverse. So it can also be interpreted as a model's preference for a highly balanced data. To the opportunistic momentum of recent encounters where the diversity is determined by differences in the data label distribution of contributed gradient. This approach averages overall of the stored gradients in the data structure gamma. And the paper argued that it can rely that the data encountered is unbalanced with respect to goal distribution. The model can overfit at the expense of the labels it encounters less frequently. And they use the 2NN and CNN for training model, which size are 778 kilobyte and 4.8 megabytes. And they set the communication environment by deploying while each data rates are 250 megabit and 2 megabit per second. The shows required encounter duration for both models. First, T sub sen is the time that the learner send the model, and T sub training is the time that the neighbor performs one round of training. Second, T sub sen is returning time. And lastly, the learner execute one round of training and aggregation. So the total of the time is given by the following equations. They compare their two proposed methods with other three methods, local training and pairwise penalty. The x-axis is the device, the model accuracy. Each shaded region is a data distribution on encounter devices. Yeah, uh, the between the 1 and 100, the 100 region is the client. I only have a 2 and 3. Their goal distribution is uh 2 and 3, and 100 between the 100 and 200 is 3, 4, 5, and 200 between 200 and 300 is 4, 5, 6. And also we can check the proposed method is converged and stable for MNIST and Cipher 10 dataset. The paper also evaluated the proposed method by introducing Levy-Work mobility model for real-world scenario. The Levy-Work mobility model is known to capture human mobility according to stochastic mobility model. In each episode, the user starts out at home and makes some trips away from home and returns home at the end of the episode. And we can also check that the proposed method's accuracy is better than other methods. Okay, this is the conclusions. The federated learning is the one-of-the-kind distributed learning method to train a huge amount of data generated and to update the model on local nodes. It can be utilized for various applications like smart keyboard, autonomous drivings, and disease diagnostics. And there are some challenging issues in federated learning, like convergence analysis, privacy and security, asynchronous communication, non-IID, and heterogeneity, and joint communication and computation design. Also, the conclusion of the opportunistic federated learning is the device can collaborate opportunistically with other devices in their surroundings using only device-to-device communication links. And they introduced their proposed method called opportunistic momentum. It provides a robust mechanism to continuously integrate learning from encounters in a way that improves overall well-informed greedy approach. And their proposed method results demonstrate that there are real-world pervasive computing scenario and application that can garner benefits. Yeah, and this is the end of the presentation. So thank you for listening. And we are going to show the opportunistic federated learning system by using the two JES Nano and laptop.